All right. So for part 2 of exponents, we're going to be looking more deeply into negative exponents. And you've seen these already, because when we practiced this rule, we had something like n to the 7th times n to the negative 10th. We found that that would equal what?
That would equal n to the negative 17.
N to the negative 3rd in this case, because we have a positive 7 subtracting a 10 gives us a negative 3.
Yeah.
So what does that mean, though? Think about it. We know that n to the 7th means n times n times n times n 7 times. But what does this mean, n to the negative 3rd? How can I negatively multiply? This means n times itself negative 3 times. What? Anyone want to guess what a negative exponent means? So remember, n to the 3rd is n times n times n. What is n to the negative 3rd? What do you think it means to negatively multiply? If we're going to multiply something negative 3 times. No. And that's the most common confusion is people think, oh, this just means a negative n. No. This does not mean negative n. Negative n would be like this, right?
It's negative n times n times n.
No. Again, good guess, because you see the negative, but it's not going to make the n negative at all.
N
N to the negative 3rd. What did you say?
N divided by net n.
You are totally on the right track. Except what you just said was this. N divided by n divided by n.
N divided by n times n.
The first one is being multiplied. It's actually going to be divided by n divided by n divided by n. But what are we dividing? Well, this will work a little better if you understand that all division is actually fractions. Remember, we've said that in reverse. We've said every fraction is a division problem. But it's also true that all division is really a fraction. So when we say divided by n, what we really mean is 1 over n times 1 over n times 1 over n. Divided by n, divided by n, divided by n. Or, we could also just say this as 1 over n to the 3rd. So a negative exponent makes a fraction. Okay? N to the negative, actually, we've been doing it the other way. Let me start again over here. So this is, I think, our 3rd rule, I believe. Could be wrong. And the rule is this. X to the negative n equals 1 over x to the n. So an example of that would be x to the negative 5th would equal 1 over x to the 5th. Huh. That's not too hard. And the cool thing about this rule is it actually it makes a lot of sense once you start seeing how it works.
That's how a lot of these exponents
It just
work.
totally makes sense. So, where we're going to see this is in more complicated problems. You'll see something like this. X to the 5th times y to the 6th over x to the 7th and y to the 3rd. And they'll say, simplify this. simplify this. We have x's in the top, x's in the bottom, y's in the top, y's in the bottom. Well, the easiest way to think about this at first, and I'm sure you're going to see a shortcut later, but is to think, oh, this is really x to the negative 7. That's why it's in the bottom. So what I have is x to the 5th, x to the negative 7, y to the 6th, and y to the, this is really a negative 3. Oh, so I just add these all up. 5 minus 7, that's x to the negative 2. 6 minus 3, that's y to the 3rd. And then the key is, you're not allowed to leave negative exponents. So I have to take this one and move it back down to the denominator. So I have y to the 3rd over x squared. So by realizing that this is really a negative 7, I can see that I just subtract it from the 5. But now look at this. Do you notice a pattern here? I ended up with this. So I started with x to the 5th, y to the 6th. I ended up with y to the 3rd over x to the 2nd. Does anyone see sort of a shortcut that we could use to get from here to here? What do you see?
Subtract the top by the bottom.
Do we always subtract the top from the bottom?
Or I mean, well, cause
So I take the 5 and subtract that from 7 to get 2, right?
yeah.
But then did I take 6 and subtract that from 3?
No, you took 3 from 6.
I took these 3 away from this 6, right?
Yeah.
Do you guys see that?
So you.
So because these fractions are really negative exponents, I'm just subtracting, right? I'm just subtracting my exponents. Let's do a more complicated one. Hold on 1 second. X to the 5th, y to the 4th, z to the 3rd, over x to the 2nd, or x squared, y to the 7th, z.
You would automatically make that z to the first.
Yeah, good. I could just write z to the first here. That might help me remember that that's a
Just a little.
1 exponent. Now, I'm just going to take this 2, this x squared, and subtract it from the x to the 5th.
So you'll get x to the
So
3rd.
this cancels out with 2 of these, leaving me x to the 3rd. Now with the y's, I'm going to do the opposite. There are more y's in the denominator. So I'm going to take all 4 of these, subtract that from 7 to get y to the 3rd, but that's going to stay in the denominator, because that's where I had the larger number of y's. What am I going to do with the z's? I'm going to take this 1, subtract it from all 3 of those, and I have z squared left up in the numerator. Give you guys a second to finish writing that. Yeah.
Can you use the restroom?
Can you wait until it's done? Sure. Can you guys still read these original numbers? That was x squared, x to
Yeah.
the 5th, y to the 4th.
Yeah.
Are there any that you can't read? If I were taking notes here, one thing I would do is, because we made this into z to the first, right? But I might make a note off to the side, something like, remember, z equals z to the first. Because when you look back at your notes, all you'll see is the z to the first. Alright, now let's do one more. What if I had n to the 8th, n to the 6th, n to the 3rd. How would you simplify that one?
Make n
N to the 5, and that's in the top of my fraction. Because that's where I had more n's. Great. Okay.
You make it m to 4. You make it underneath this bigger.
Right. So I'm just taking these 6 away, and there's 4 left in the bottom. And that's it. If you guys want to take a picture of the board, that would be a great time. A couple of examples. It didn't come out too well. Alright, do you know that on the iPhone, if you tap where you want it to focus, it'll
I
focus
tried,
there?
just stay.
Huh. Feel free to come closer. Alright, I'm going to give you kind of a tricky one. X to the 5th over x to the 5th. What do you think that equals?
X to the first,
It would just be x.
or we'll make x equals x to the first.
It would be 0. Okay.
It would be x to the 5th.
These are all interesting ideas.
X to
How
the
could we
5th.
find out for sure what that equals?
You can't use a
Subtract
calculator.
5 from 5.
Subtract 5 from 5,
X
right?
to the 0.
X to the 5 times x to the negative 5 equals x to the 5 minus 5 equals x to the 0. But what is x to the 0?
Nothing.
So you think x to the 0 equals 0?
Yeah.
I have a question. Look back at this first problem. What if I had 7 over 7? What is 7 divided by 7?
1.
1.
So it's just
What
x.
if I had 9 over 9?
1.
1. What if I had 127 over 127?
1.
What if I had 2x over 2x?
1. X.
1. 1x?
One.
Or
Just
1?
one. Just one. Just one.
Yeah, just 1. What if I had x over x?
1.
1. Doesn't anything over itself equal 1?
Yeah.
Anything over itself equals 1. So really, x to the 5th over x to the 5th should equal 1. But we said that it equaled x to the 0 power. So does that mean x to the 0 power equals 1?
Yeah.
It does! Anything, this is one of my favorite rules. Anything to the 0 power equals 1. Right? I could give you some super complex looking problem, right? Minus 1 to the 0. Guess what that equals?
1.
1. Anything to the 0 power equals 1. Except for one thing.
Oh, wait. There's more.
What do you think would be the exception?
0 to the 0.
Yeah, 0. So we can't have 0 over 0, right?
Yeah. That's
This is
just.
called undefined.
You can't do that. Math doesn't let you.
So we will never talk about 0 as a base for an exponent. Now, 0 squared is obviously 0, right? 0 times 0 is 0. But we're gonna just kind of avoid using 0 as one of our bases because it gets a little tricky with all of these rules. Okay, let's review all of our rules. Rule 1. What did we say for rule 1? X to the n times x to the m equals x to the n plus m. An example of that, z to the 5th power times z to the 7th power equals z to the 12th power. Okay. Rule 2. X to the n to the m equals x to the n times m. For example, I'm going to do an example that includes the thing that was throwing some of you off. 2x, let's do 2x to the 3rd power all to the 5th power equals 2 to the 5th power x to the 15th power. Rule 3, we said x to the negative n equals 1 over x to the n. And our example of this is a little weird because it's really like rule 1 and rule 3 combined. We said something like x to the 5th, y to the 4th, z to the 3rd over x to the 3rd, y to the 5th, z, and then we would subtract those, so we get x squared, z squared over y. And now our last rule, x to the 0 equals 1. Example, anything to the 0 equals 1. Yeah, go ahead and take a picture of that, if you would like. I'm trying to help you guys remember to do that as part of your note-taking.
It's not good. There we go.
Jackson, John, do you guys have a way to take a picture?
Before you erase it,
Program?
can I copy it down?
I keep it together.
I'm gonna stop the video because we're
Okay.
taking pictures.